So in the last lesson for the unit, we're going to go back to a couple other things we can do with rational equations, so those equations with variables and also fractions. So the first thing we're going to go over is those lovely equations that have multiple variables, and we're solving for one of them in terms of the other ones. So in this first equation, I see I have an x, a y, and a z, and I'm trying to get the x by itself. So whatever it says we're solving for, that's what's going by itself. So we're going to start out and treat this like a normal rational equation. So if I see these three fractions, I see addition or subtraction, I know I need to find an LCD. The LCDs won't be super hard with these. All the problems we do today are monomials, so my LCD is an x, a y, and a z. I'm going to rewrite my equation just so I have a little more room. So to get to the LCD, my first fraction is missing the y and the z. My second fraction is missing the x and the z. And my third fraction is missing the x and the y. So I end up with, as my next step, yz over xyz plus xz over xyz. And I do write my z's with a line in the middle so they don't look like 2's, because that's always something we want to avoid. So now I'm going to combine, oops, it should be an equal sign. Now I'm going to combine these two fractions together now that I have my LCD. So I get xy, or xz plus xy over xyz. And over here, this fraction is staying the same. So remember, the whole reason that we got an LCD is because now we know because we have an equal sign, we can multiply both sides by the common denominator and cancel out the common denominator. So far we haven't really even thought about what's new about what we're doing. So now we're to an equation without fractions, and now we can think about what we have to solve for. So I need to solve for x, and typically that just means moving things away from x. But the problem here is that I have two x's. Okay? So a lot of times this happens with irrational equations. We can't really solve for both of them at the same time, so we want to do something so we've only written x once. And what we can do here is we can notice that we can take out x as a GCF. Now I only have x written once. It has multiplication, so the way I'm going to get it by itself is by dividing. Nothing simplifies on this left side of the equation because we have addition in the denominator. So this is solving for x in terms of y and z, which means that y and z will be on the other side of the equation. So just to practice with that, we're going to take the same equation and just try to solve for a different variable. So now we're going to take that same equation and solve for y in terms of x and z. So I'm going to go back and get that equation. I'm going to do the beginning pretty quickly because those steps are going to be the same. So I see my equation, right, LCD, multiply by what's missing. And I'm actually going to skip a step and just write the fractions combined since this beginning is the same. So I know I have my LCD, so I can add the two numerators together. So from here, multiply by the common denominator because we have an equation. And now we have our equation to work with. And we're going to have to do one more step, but it's not really any different in terms of the plan. So I'm trying to solve for y. I see that I have two y's, so that means I need to get them together because the only way I can factor them out is if they're on the same side of the equation. So I'm going to subtract xy over. So I get yz minus xy equals xz. Now that they're together, I'm able to factor out the y. And now that I only see the y once, I am going to be able to divide. So now I have solved for y in terms of x and z. So here is another equation, and I would definitely start to try some of these on your own. There's one more on the next page too. So now we're going to be solving for b in terms of a. And I won't really think about that till the end, right once I get rid of my fractions. So steps are LCD. So this fraction's missing a b. This fraction is missing an a. And over here, I am also going to get the LCD. So I can do the multiplying step. So if I'm starting to get there, I know my denominator is the same over here, and there are a lot of steps here, so maybe I skip a step and I just write what I have. So in my numerator, I have b plus a squared plus 1. And that's something you can definitely do. Just be careful if you have to distribute a negative. That's usually where that doing too much at once can get messed up. So now I'm going to multiply both sides by ab, because we have an equation. And I get b plus a squared plus 1 equals ab. I go back and remind myself I want to solve for b, which means I have to have all the b's on one side. So now that the b's are together, I can factor it out. And then now that there is only one b, I can divide. So final answer is b in terms of a. We're going to do the one on the next page just because it's of a similar topic in the same video. So this is actually a situation that's going to come up next unit when we start to do inverses. So you can imagine, and you can kind of see it, that I had some equation, I switched x and y, and now I have to solve for y. So looking at this, I could get an LCD on both sides, okay? But since I only have single fractions, I can also just multiply both sides by y plus 2. That'll cancel this denominator, and I end up distributing on that side. So it's just a different way if there's only a single fraction on each side. Similar, if you think about it, to cross multiplying, that is why we can cross multiply. So I'm trying to solve for y in terms of x. So I find my y's. I want to get them together, but I also want everything else on the other side. So there's always an option of like which way to move things. I'm going to choose to move the 1 this way, and the xy this way. That keeps the most stuff positive. That's not a general rule that we have to do. So on this side I have 2x plus 1, cancel, and on this side I have y minus xy. So now that my y's are together, I factor it out. I divide. And I get 2x plus 1 over 1 minus x. If I had chosen to move things in the opposite order, this also would be a valid answer. Basically, all the signs would be changed. So that we'd have like the 3 negatives, right? And then the 1 would be, the x would be positive. Okay, so either of these are fine. Probably more likely you have this one, but this is also a valid answer.